This is Professor Derf Seitz. This Java tutorial focuses on two-dimensional array iteration patterns. A two-dimensional array is an array consisting of row arrays. Each row is a one-dimensional array, and there may be a different number of columns in each row. Some key properties of a two-dimensional array: remember, every array is an object type in Java, and there's a field called length. So if you take the array name, the length property of the array of a two-dimensional array is the number of rows. If you index the array name with a index I, you'll be looking at row I, and it has a length property because each row is an array. That's the number of entries in that row, the number of columns in row I. To access array elements, we use the array name with the row index and the column index, and they're zero relative. Here is a very complex looking statement that's used to access the last row and last column of an array. If we break it down, it has array name. The first square brackets are right here. That's the row index. So it's going to access row array name.length, which is the number of rows, minus 1. That puts you to the last row index-wise in the array, because the indexes go 0, 1, 2. They're always one less than the row numbers, which go 1, 2. Row numbers is how we talk about rows, but in Java you have to use zero relative indexing. Then the column index for the last column, this last set of brackets here, first of all it takes the array name and then indexes array name.length minus 1, so that will be the last row index-wise, and then its length property gives you the number of columns, and 1 less is the index of the last column. Keep in mind that when you use array indexes, if they are negative or if they go beyond the size that was declared for the array, you'll get an array index out of bounds exception at runtime. Here's our first iteration pattern to process all the elements of a two-dimensional array row by row. We have nested for loops here, an outer for and an inner for. Looking at the process comment in the middle of this pseudocode here, because it's not really being compiled or anything, it's just showing the pattern. We are referencing array name row I, column J. The outer loop varies I, so it's going to go row by row. I starts at 0 for the first row, increments by 1 each time, and goes all the way up until the number of rows, but 1 less than it, less than that, because we're dealing with zero relative indexing, row by row. For each row I, we then want to process every column entry in that row. So we have a for loop with a loop control variable j here, starts at 0 for the first column, goes up by 1 each time, and it wants to go up until but less than array name sub I, that's row I, the length of it, the number of columns in that row. So it wants to stay less than that, and it will process all the columns in that row and then go to the next row. The next iteration pattern here, process a given row I of a two-dimensional array. That means each column in that row. Our process statement has a row I and a column j. I is the row. So we're going to vary j, the column index, from 0, the first column, keep bumping it by 1 each time, and go to row i's length and stay less than that. The next iteration pattern processes a given column of a two-dimensional array. Remember, a column goes down across the rows, like column 0 goes the first entry in row 0, the first entry in row 1, all the way down. Our process statement here again uses row I, column J. We start going through the rows one by one. Row 0, bumping by 1, and staying less than the number of rows. So that's going to, our loop there is going to take us row by row. Inside that loop, we do not have an inner loop, we have an if statement in there. Now we're going to look at J. J is going to be the column that we're interested, that we were given. If J is less than that row's array name sub i's length, that means it's within the valid columns of that row. It's not a hole, it's not a missing spot, it's not beyond the end of that row. Then we can go ahead and process the array entry ij. If not, if j is beyond what's the valid length of that row, the if statement just doesn't run, and we don't have anything to do in that row because the column doesn't exist in that row. Our last iteration pattern is to process all elements of a two-dimensional array, this time column by column. So you're going to process the first column and then the next column. So you're going to go down across the rows column by column. We are going to need here a max number of columns in this iteration pattern, be the number of columns in the largest row. We start varying j this time. In our innermost statement here, I and j represent rows and columns. So we're going to vary a column from 0, going up by 1, and we're going to go all the way up until that max number of columns, but one less than it, because there's no need to go beyond there. There will be no more column entries in any row beyond there. So that's what our outer loop does. Our inner loop, where we're now going down that column, changes the row, and now we're going to go through every row, starting at 0, bumping by 1, all the way through the array. In the row, we'll do code similar to what we did in the previous iteration pattern. We'll do an if to make sure we're not beyond the length of that row, make sure we really have a column that exists in that row. If so, we process it. If not, we move on to the next row. So these are some useful patterns. You don't have to memorize how to code these things. That's the purpose of patterns. The time is taken to create them, and then you can refer to them and use them in your code.